Hello.
Okay.
Good morning to sir. One second, sir. Good morning to one and all present over here. On behalf of Parul University, I am thankful to Khodiar Care Center for arranging such a webinar. Today's webinar topic is on the importance of design engineering software for the various engineering fields. We are having two experts today. Mr. Jiten Goswami sir. Sir is a center head for the Khodiar Care Center India Private Limited, and second is the Mr. Kapil Rathod. Sir is a technical manager in the Khodiar Care Center. So I welcome both of the experts today, and we'll start the webinar now. Sir, Jitan sir, you can share the screen.
Yes. Thank you, sir, for such a warm welcome and introduction. Uh, I'm sharing my screen.
Yes, sir.
Okay. So, uh, in association with Parul, we are going to present you with a webinar on importance of designing software and why are they used. Okay. So, first of all, I will introduce myself. My name is Chitan Goswami, and I'm basically a mechanical engineer with experience in planning, quality, and design engineering. Okay, and I know various designing softwares and use them for various purposes, and also train professionals as well as students. And my colleague is Kapil Rathore, and he is also a BTech civil engineer, and he also has knowledge on various civil engineering and architectural softwares. He works on various projects and also trains some professionals and students over here. Now, what is Korea? Our group was founded in 8th December 2003 and with an aim to inspire and create professional in design field. And it was the first center in Ahmedabad regarding CAD. And we trained almost 40,000 students till now. And right now we have centers across Gujarat state, like in Vadodara, Surat, Ahmedabad. So main cities are centers are there. And we have services like software sales, software training, and services like projects and various needs of the industry. Today's agenda. So we are going to look into designing versus drafting. What is the difference between these two? Second is importance of designing software. Third is design software used in civil and architectural fields. And Kapil sir is going to explain it about it. Design software used in mechanical and automobile fields, and then Q&A session will be there. And lastly, we will explain you about the courses that we offer here. The first is drafting and designing. What is the difference? Basically, drafting is your creation of accurate representation of your designs that you make in any software or in any field, like civil, architectural, mechanical, or even electrical. Okay, and after the designing, the next step is manufacturing or making the thing in real world. And for that, you have to communicate your designs accurately to the workshop or whoever the person who's going to make the actual product. And for that, you have to draft your designs like engineering drawings. So you have to make views, provide symbols in there, provide some dimensions, tolerances there. Okay, and all of the things should be there to communicate accurate manufacturing instructions.
Previous we are working on the paper, like we are taking the paper sizes and we were drafting on that paper, okay, with the help of a scale, pencil. So this is the transformation. Software is the transformation of that part. Like in this software we are doing this work only, but in accurate measurement and dimension.
Yes, the accuracy is the main part, and it is also increases the productivity. So basically, drafting for drafting we use AutoCAD, and for designing there are various software that we are going to cover later. And what is designing? Designing is the process of creating a product or any engineering product according to the market demand and according to problem that you have on hand. And to solve that particular problem, you have to apply your engineering knowledge, the feasibility study, okay, and you have to also look into cost and manufacturability of it, and what are the supply chains issues are going to be.
which we will put our thoughts that will be considered as a design. Okay, like we have to design one part. Otherwise, we have one plan. We have one area. So we have to planning according to that area. So this will be considered as a design. In the drafting, we will just see and we will just draw. It will be the part of the drafting.
Okay, designing is a very complex process, and you must have an engineering mindset, and the fundamentals of your engineering field should be clear. Then and then only you can design any product. Now, what is the importance of software in this field and how they are useful? Okay, so designing process involves concept creation, material selection, process selection, problem solving, and estimation of the cost and required materials, and the designing software make this process relatively easy. Okay, and why they are used? Their advantages is like quick concept design. In previously, before the software was used, you have to concept design on your paper, and concepts were not very easy to design. You have to make some calculation, you have to make the geometry basically manually, and that was very tedious process. Now you are going to design everything in the software, and the second advantage of it is quick concept and product visualization. After you make your 3D part, you can quickly visualize it, and you can see like it is in real world. So you can communicate your design with your client or whoever wants to know your design very efficiently and very quickly. So that is the main advantage. What is third advantage? Increased productivity. So obviously, when you design on pen and paper with pen and paper, and when you design on software, the productivity increases by multifold. Okay, like if you are designing something in mechanical field, so you have to just think about the requirements that your product is going to solve, and then you have to uh, carry out the study about the dimensions that are required, and you have to make that geometry in the software, and readily you will be have a 3D model. Fourth is improved accuracy and decreased errors. So in your model there will not be any errors, okay, because software don't make any mistakes. And on pen and paper you can make mistakes because there is a chance of human error, but software don't make any mistake. If you draw 100 line, then it will be accurately of 100 not plus or not minus. Okay, so reduced error and improved accuracy. Next is quick sharing and collaboration. So in today's era, not a single person designs a very complex design. A whole R&D team is working behind the product development. So the sharing is very essential, and you can share your ideas and concepts with your team very effectively via network. So you can directly send or share your product or your concept easily via network, and you can collaboratively work on the same product, and you can come up with greater ideas and greater results. And lastly, the automation. Now the CAD softwares are now automating the process of drafting. Basically, in some years, the drafting work will be automated, and the engineering drawings will be generated automatically in some years. The work is in progress, and API search about the APIs and what are the automation languages that are used for automation in CAD software. But it is going to come very soon. So it is also automating the process of drafting and some of the day-to-day tasks. Now, Kapil sir will explain you about the software that are used for civil and architecture engineering and what are their importance.
Okay, so in civil engineering and architecture field, softwares are very necessary. We cannot do any work with the help of a pen and paper. Just a basic planning we can do, but for the accurate plans, 3D models, we have to use the softwares. So there are multiple software that we are using in our field, like in civil engineering and architecture. Okay, so that softwares are like AutoCAD. So first software is AutoCAD. AutoCAD is a basically drafting software. We can do 2D work with the help of AutoCAD. So AutoCAD basically we are using in all the fields like civil, mechanical, electrical, chemical fields. In all these fields, we are using AutoCAD software. So basically, use of the AutoCAD is to make a 2D drawing, like we have to make any construction drawings, so we will use AutoCAD software. Okay, so all type of drawing, like we have to make a center line diagrams, we have to create a floor plans, we have to create structure drawings. So in that we have suppose we have to create brick drawings. So in this all type of drawings, we can use AutoCAD software. So this all type of drawings we can create in AutoCAD. So basically AutoCAD is a command based software. So if you want to draw a line, you can use a command. Okay. So there are many parts we can consider in AutoCAD. Like we can first create a drawing. So there will be the draw tools. Like if you have to modify your drawings, you have to use your modification tools. So basically first we will create any 2D drawing, then we will create any working drawing. So for creation of the working drawing, we will use dimension, taxes. Okay. We will also modify dimension. We can modify dimension like if you can modify units, like in if you want to work in meter, you can change the unit. And there are also other units like feet and inches. So you can also work in feet and inches. So in any unit we can work in AutoCAD. So basically, like after creation of the working drawing, we can also put the blocks. Like there are many furniture placed in this drawing. So these all are the blocks. So blocks can create accurate furnitures, like also it's reduced the time for the creation of the drawing. So ready-made blocks we can also get from online platform, otherwise we can also create our own blocks. So this is the basic floor plan. Second drawing is structure layout. Like any structure drawing we can create in AutoCAD. So this is the beam and column section. So we can show the rebars, we can show the number of diameters of the bars, how many numbers of rebar we have to use for the construction. So these all detailings we can show with the help of AutoCAD. So basically in architecture field, in construction field, we can use the AutoCAD. Third drawing is regarding to the elevation. So this type of 2D elevation we can create in AutoCAD. So like we can also provide the detailing, like what is the length height, what is the sin level, what is the slab level. So these all things we have to justify in our drawings. Then we can get all the proper drawings. Okay, this is the section layout of total floor area. So in this, we have cut section from the states, so we can see the proper accurate section and proper dimensions we can present via cutting the section. So this type of sectional drawing also we can create in AutoCAD. In other field like transportation, so we can show the bridge layout, we can show the dam layout. Okay, so all type of 2D layouts we can create with the help of AutoCAD. Okay, so this is all about the AutoCAD. Second software is Revit. Okay, so Revit is basically BIM software. and Revit we are using for the 3D model creation. So BIM means building information modeling. So first we will see what is the meaning of BIM. So as I said, Revit is a BIM software. So BIM is a digital representation of any building model. And BIM is a process for the creating and managing information on a construction project throughout its whole life cycle. Okay, like from the construction to the demolition, whole process we can show with the help of Revit. So in the software only, we can show all the processes, like how much excavation we have to do for the construction, where we have to put the plinth area, what will be the 2D layouts, how to create the 3D, how to create the sections, elevations, all these things, all technical drawings we can create in the Revit software. Okay, so Revit will give us total information of a whole building life cycle. So, and what is the advantage of Revit behind using this software? So why to use it? So Revit will give us 3D designs. When you create a 2D drawings, Revit will give you automatically 3D models. You don't need to create any 3D model separately. When you will create 2D, automatically 3D will also create. Second thing, elevation and sections. After creation of your whole the 3D model, just you have to create a single line. You don't need to create section separately like manually. Just with the help of a single section line, all bending will be cut and you will get a 2D and 3D section layout and elevation also. High quality materials. Uh, for the rendering purpose, we can show all type of materials like concrete, brick. For the interior, we can show the different type of textures for the walls, for the floorings, all type of textures we can show in this software. For the exterior also we can present different type of material, and then only we will get a good render outputs like final outputs. For most important part is the schedule and quantity. So schedule means I have one 10-story building, and I have used 100 doors in this building. So Revit will calculate all the parameters of doors, and it will give us a total schedule layout. You don't need to create a separate schedule in Excel sheets. Okay, Revit will automatically create one action, and you will get all the information regarding that doors, like what will be the door, or the door width, door height, what will be the sill level, what will be the lintel level. So all the information you will get directly. You don't need to create any sections action sheet. Okay, so this will be the part of the schedule. Like you can prepare the schedule of doors, windows, furnitures, any component you can use and you can present via scheduling. Second part is quantity. So you can find the materials, like you have to find the volume of the concrete, number of bricks, what will be the cement volume, cement weight, number of bags of cement, sand, aggregates, quantity of the water. So all type of material Revit will create automatically. So totally estimation work we can do with the help of Revit. Okay, we don't need to find, or we don't need to calculate parameters for the estimation. That thing Revit will give you directly. So this is the main advantage of Revit. Design options. You can the design option means you can give the choices to the client. Like in a single floor plans, you can give multiple choice, like clients asking for 3 to 4 layout plans. So in single layout plan you can give the information regarding 4 layout plans. You don't need to create four separate files for the Revit. In a single file, you can give the choices, you can give the options to the clients. Work sharing and collaboration process. In this process, we can share our work to the other person. Like I am a project owner and I have to share my work to the multiple people. So from here only, I can share my work to the peoples that will be the complete the work and they will again submit that work to me. Okay, so we can do work share. High resolution renders. High resolution renders means we will get a final image in that how our model will be appear. That thing we will get a final output too much better as compared to AutoCAD. So I will show you some render output. That output will be the final output of the Revit. Walkthrough, we can also create a 3D animation. Like we have to enter in a house, we are uh, we are going in any room. These all 3D animations we can create in Revit. Okay, so this type of big projects we can handle with the help of Revit. This type of projects is not possible to complete in AutoCAD. So this is the render output. Like this all things I have created in Revit. Like you can see, we can do topography work. We can place the trees. We can create a path. Also, we can put better materials. So this is the render image. So this output we can get in Revit. Okay. Next software is 3ds Max. So 3ds Max is basically visualization software. 3ds Max will not give us any technical details, but render output we will get too much better as compared to Revit. But we will not get any technical details like planning, elevation, section, scheduling, material estimations. These all things we can get in Revit, but not possible in 3ds Max. So 3ds Max generally uh, we can use for the rendering purpose, and we can get better, much more better render output. So this is the Autodesk software. Autodesk is the company name. AutoCAD, Revit, 3ds Max, all these softwares are product of AutoCAD or Autodesk. So 3ds Max is 3D modeling, rendering, animation, and composite solution for various enterprises. Like in the 3ds Max, we can create our whole model. There are four parts, like creation of the model, then we will apply the materials, we can provide the lightings, and finally we will uh, create a render process. Autodesk 3ds Max is commonly utilized by civil engineers, architects for a 3D perception of their designs. So actual designs we can present via 3ds Max. I will show you some output of 3ds Max. Before that, we will see why to use it. 3ds Max will give us free form modeling. So generally free form modeling, like we can take an example of any sofa. You can take an example of any chair. These all things are very flexible, like it design very free formly. So free form modeling we can do, like any type of modeling you can do in 3ds Max, like sofa creation, any type of furniture creation, any type of like you can also design the trees, you can design any type of free form modeling you can do with the help of 3ds Max. Second thing is easy conversion of 2D into 3D. So in this topic we can use our AutoCAD 2D files. Then we can import the 2D drawings in 3ds Max, and we can tag the references and we can create the 3D. So for the 3D creation, we will use 3ds Max and we will use the command of the 3ds Max. But for the reference, we can use a 2D drawings from the AutoCAD. In the 3ds Max, we will get a number of type of modifiers. Modifiers means if you want to create a cloth, so you have to use a modifier. You have to scale your material, so you have to use material. So there are many type of material, modifiers. So with the help of that modifier, you can modify anything in 3ds Max. In 3ds Max, you will get the predefined Autodesk material library. In that library, we will get ready-made materials like brick texture, floor materials, any paint, wall paints, exterior materials, all type of materials like mirror, glass. All these things we will get directly in 3ds Max. Also, if we want to create any material from our hand, we can also design any materials from our side also. So in 3ds Max, material output will be much more better than any other software. So this is the render output of 3ds Max. So this is all about freeform modeling. Like this is the pillows, this is the sofa. This is basically depends on the freeform modeling. So these things we can do, and this type of output we can get with the help of 3ds Max. So so what difference is between Revit and 3ds Max? Revit is a technical software, and 3ds Max is generally non-technical software, and Revit is also parametric software, and 3ds Max is non-parametric software. In the Revit, if you are going to create anything, you can change the parameter directly, but in 3ds Max, that things will be not possible. So if you want to get this type of output, you can use 3ds Max, and if you want any technical details, then you have to use Revit software. So this is the second render output of 3ds Max. Okay, this is a totally interior design. So this type of designing we can do in 3ds Max. So basically interior designers are using this software. So we can show this type of material output. We can create different type of lights. This is the Dix light. This is the line light. This is a different type of lights that we can create in 3ds Max. And finally, after creation of the modeling, after creation of the material lighting, then finally we can put our system on renders. So after completing the render process, this output we will they get. Okay, so this is all about civil and architecture software. Now Jiten sir will present you software used for the mechanical and automobile engineering.
Okay. Thank you, Kapil sir, for explaining civil and architectural software in such a informative way. So now for mechanical, automobile and relevant field students, I'm going to explain you about the design softwares that are used for these fields. Okay, and all of you must have come across some of the software that are used in designing field, and you will be eager to work in designing field. There are different fields that you can work uh, in an industry after passing out your degree, like there is production, there is quality, there is maintenance. Okay, there is marketing, there is purchase, and then there is design. Okay, but designing is your core field, core mechanical or core engineering field. Okay, because you have to implement your knowledge that you have learned during your degree, and you have to create real world products, solve real world solutions, and create the designs and concepts. Okay, so some of the fields are core fields, like design is there, is your core field, and what are the softwares? So first software, as Kapil sir already explained you about AutoCAD, I'm going to just give you some advantages about AutoCAD regarding the mechanical and automobile fields. So why AutoCAD in mechanical or any relative field? Like improved quality and accuracy over hand drafting. Okay, uh, in previous times, people were used to draft the drawings using their hands. Okay, pen and pencil. Even today, engineering colleges uh, carry out this practice and train students in that. But why is that? Because students should have to imagine the drawings and imagine the 2D drawings from the 3D models, and from 2D drawings they have to imagine the 3D model. Then and then only that knowledge can be applied in AutoCAD. So that engineering drawing subject is very important. Okay, if you can't imagine your product, then you can't design your product. Okay, the drafting for detailed drawings of the components and assemblies. Okay, so you can quickly draft your drawings in detail with dimensions, with tolerances, and you can also create assemblies. And for that assembly, you can also create your tables like bill of material. In bill of material, you can also have quantities, like how many bolts are there, how many components are there, which component is made of what material. So okay, so such kind of tables can you can create there. Drafting for piping layouts. So AutoCAD is still majorly used for piping layouts in big chemical companies also, like IOCL, ONGC. Okay, we have also done projects for them. So for piping layout, AutoCAD is still majorly used. Okay, and easy and quick modification and revision of the drawing when used for drafting. So you can modify your existing drawing very quickly using modification tools such as mirror, copy, offset, then such kind of scaling option is there. Okay, so these tools make modification process very easy and very quick. Like if you want to modify your drawings in half an hour, and if you know modification tools, then it will cut your time in half. You can do it in 15 minutes. So those commands are very important. This is the output. Okay, this is a mechanical assembly, and you can see that there are some bolts, there is isometric view, there are some of the elevation is there, side view is there. Okay, and you can create any kind of view in AutoCAD with dimensions, with tolerances. Every detail is there. Okay, you can show your GD&T tolerance, normal tolerance, plus and minus tolerance, symmetric tolerances. Then there are welding symbols. Okay, fabrication, different kind of surface finish symbols. So all symbols that can be possible in an engineering drawing, you can get in AutoCAD. And then there are tables. So you can see here there is a table of bill of material. It contains all the information about parts, like what is the part number, what is the quantity, description of it, what is the material that is it is made of. Next is your piping layout. So this is a piping layout, and I'm showing the drawing of IOCL. Okay, this was one of the project that we had done, and you can see here that there is a piping layout here. The white lines that you are seeing here are the represent pipes, and these are the component like tanks. Okay, and these green symbols are valves. Okay, different kind of valves has different kind of symbols, and those are the blocks. You can create a block of valve, and you can repeatedly use that block everywhere. Okay, you don't have to create valve every time. You just use your block there, copy paste there, and you can create an array also. Okay, then there are some of the tank symbols, tank different kind of information is there. Okay, what kind of valve is there, all the information is there in your drawing. And such kind of very complicated piping layout can be, this is relatively easy by the way, but okay, in detail you can show any detail here. Okay, like pumps blocks are also there. You can also show pump blocks, what kind of pump is there. Okay, so AutoCAD basically makes your drafting process very easy, and over hand drafting it saves a lot of time, and you can quickly modify existing drawings that you have in AutoCAD also, because a lot of the times uh, let me guess, 90% of the times, you have to just modify your drawings. Only 10% of the time you have to create a whole new drawing. Okay, so client requirement is basically will be based on your existing product line. If you are new company, then and then only you have to create new designs. But the established companies also have their product line ready. According to customer needs, they just change design day to day. So modification tools will be very helpful in that, and AutoCAD is very helpful in that. So this is your AutoCAD, and this is the output that you can get in AutoCAD. Now, from moving on to drafting from designing, you can use this advanced software, and one of this software is SolidWorks. It is product of Dassault system. Okay, Dassault system has two products in designing. One is SolidWorks and one is CATIA. Okay, SolidWorks basically focused on machinery, then heavy machinery, aerospace, automobile, product design, and other industries. And CATIA is basically solely focused on aerospace industries, like complicated. You can make your complicated surface design in CATIA. But SolidWorks is an all-rounder software, and you can design any machines, okay, any consumer products, okay, like headphones, mobile phones, then uh, industry related products, okay, like pumps, motors, generators, turbines. Okay, so such products you can create easily in SolidWorks. You just have to have knowledge and engineering background and skills regarding that product. These are the tools. Okay, software is just a tool. Main thing is your knowledge. If you don't possess any knowledge, software cannot make design on its own. Okay, so it makes your designing process very easy, and I'm going to show you some of the products in uh, slides coming. The next is Creo. Okay, and why is Creo used? So Creo is basically very powerful software. Okay, just like SolidWorks, they are basically, I can say, they are competitors, but they are used in various fields. Okay, some companies use Creo, some companies use SolidWorks, and all over the world these softwares are used. Okay, and basically these two are CAD softwares. CAD stands for computer aided design, but these two also possess capability of analysis. Okay, CAE, computer aided engineering, and they also have some CAM capability also, like computer aided manufacturing. Okay, CAM is basically a different field. You have to make programs for machines like CNC machine in CAM software. For that, there are different softwares like Mastercam and NXCAM, but today we are not going to cover those softwares. So Creo is a PTC University product, and it is flagship product of PTC University, and it has several modules, and such as modeling module, assembly module, drawings module. Then you get rendering module. Okay, then Creo Direct is there. So it is module based software, whereas SolidWorks was everything in one software. It has plugins in it. Okay, so basically the capability will be the same, only the modeling process will be the different. Okay, what you can make in SolidWorks, you can also make in Creo. The process and the methodology only will differ. Okay, what is the output and why SolidWorks and Creo is used? What are the advantages? Why not use AutoCAD only? Okay, so AutoCAD is not used because it is not parametric software. Now, what is parametric? Parametric is like if you want to create a design, then you have to have some parameters for it. Okay, like you have to know your dimensions. Okay, and what are the dimensions going to be of the product? Overall dimension like length, width, and for every feature there should be dimensions. Two kind of dimensions are there: location dimensions and size dimensions. From these two type of dimensions, you can create any design. So one parameter is your dimension. Then the next is your relations. Okay, then there are geometric relations, like you have heard before, okay, from schooling time, like parallelism, perpendicularity, concentricity. Okay, then collinearity. Okay, so such kind of geometric relation you have to provide, and then those relations will capture your design intent into your product. Okay, and it will stay there until and unless you delete those relations. Okay, so it is very advantageous when you want to edit your design. Okay, it is not possible in AutoCAD. AutoCAD in AutoCAD you can create your design, but editing is very difficult. Okay, I'm talking about 3D models, not 2D drawings. Okay, so first your advert is parametric, as I explained you. Second is associating. If you create any product in these two software or any parametric software, it has associative capability also. Like I have, for example, I'm creating an engine, okay, IC engine, and I have created a piston model for various engine. Like my company is using the same piston of same size in various type of engines, but the same piston is used. So in 10 assemblies, same kind of piston is used. Now I have detected a problem in piston and I have to change it. Now my drawings are ready, my model is ready, and I have used all the piston in all the assemblies. Okay, like 10 assemblies, and now I'm getting the problem. So when I change the dimensional parameters of my piston in the original model, the changes will automatically reflect in all the assemblies and all the documents that I have used. Okay, and like I have used piston in 10 assemblies, so that change will automatically reflect in all those 10 assemblies. Okay, so it saves your unnecessarily editing time. Okay, which is not possible in non-parametric, non-associative software. Okay, that's why industries use this software and not AutoCAD or any non-parametric software. And then there is automation. Okay, as I've said earlier also, you can automate your drafting process. Okay, the views, you like AutoCAD, in you have to draft your views, you have to make front view, you have to make right side view, you have to make section view, you have to make detail view. But in these softwares you get the views ready made. You just have to place them, and you have to place the dimensions and tolerances. Okay, so it automates many of the things and saves your time. And then there is a huge community. Okay, over internet there is huge community. uh, Good users, good number of users are there. If you use LinkedIn, you can get a very huge user base. Okay, softwares using personal. Okay, in the industry, as well as students are also there. There are channels, groups for these softwares. Okay, you can get help very quickly. And then the main thing is employment scope. Okay, if you want to establish your career in designing field, then you must have knowledge of some parametric CAD software. Okay, then and then only you can establish your career as a design engineer. Okay, on basis of AutoCAD you can get job of a draftsman, but for design engineering you have to know this software, because industry nowadays use this software for design. Okay, like I can mention some of the industries of Vadodara region. Like there is L&T. Okay, L&T. Then there is GEA. Okay, that is also a huge company. Then there is GIDC areas. Okay, so many companies are using this software for designing purposes. Okay, so first is how you can create parts. So as you can see here, this is a bearing house that is used in a assembly called centrifugal pump. Okay, and this housing contains some bearings, and there will be this will be bolted on the housing of pump. Okay, as you can see here, there are various features. So these software are feature based. Okay, like I can give you some example that these four cuts are there, these holes are there, all these are features. Then there are holes, threaded holes are there, and for threaded hole there is inbuilt feature specifically for threaded holes. Okay, you just have to know the what kind of threads you are going to make there, and you just have to click there. Okay, and the hole will be automatically appeared. And then there are several cuts there. Okay, this hook is there. Okay, these two cuts are there, and you can do it very quickly using some of the commands like mirror, patterns. Okay, it looks very complicated, but it is very easy to make. And those parts will be assembled in assemblies. Okay, as you can see here, this is a whole centrifugal pump assembly. You can see several parts here. You can see bolts, you can see impeller that is rotating in there. I have made this whole animation in SolidWorks only. Okay, you can make this in Creo also. So you can make these assemblies, whole assembly with every part. Okay, every part that you use to create this assembly in real world. Okay, and you can see then see that you can quickly communicate your design to the clients or anyone who is interested in your product. Okay, you can show the animation to them, and you can assemble whole assembly like in real world. You just have to know which part is going to assemble where, and the remaining process is very easy. Software makes it very easy. Okay, like there is coupling is there. Okay, the shafting is there, impeller is there, housing is there. All these will be all these parts were made in a part modeling environment. Then this assembly was made in assembly environment. Okay, and then there is this base frame. Okay, it will be made in wind bends portion. So this kind of complicated assemblies you can also make in SolidWorks or Creo, and this is relatively easy. There are assemblies that contains 2000 or 3000 parts also. Okay, those assemblies are also possible in these softwares. And then there are drawings. Okay, so this is very important part. As a design engineer, or your final output will be your drawings. Okay, no one is going to ask you for 3D models, and no one is going to demand you about the 3D model files. But only the thing that production engineers will demand you is engineering drawings, and then only the production will start. Okay, for example, there is a uh, casing here. Okay, pump casing, as you have seen in the assembly. So you have to communicate every detail of the casing. You have to provide a dimension of every feature. Okay, for example, let me show you that there are these 8 holes. Okay, and what is the size of these 8 holes? It is shown here like m8 into 1.0. So you can the worker who is going to make these holes will make out from this that he has to make m8 threads with the pitch of 1.0, and the quantity is 8. And for the depth information, you can go any of the section view. Okay, there is the section view. You can see the whole profile is there, and from this information you can also create your 3D model. You can also reverse engineer it. For this volute from which the water is going to pass, the information is here, like what kind of spiral is this, what is the pitch of it, what is the revolution. Okay, and all the dimensions like angles is there, the radius is there. Okay, the diameter is there, thickness is there. So you have to communicate each and every dimensions that is required for manufacturing it. Okay, so this is the part drawing, and this is assembly drawing. Okay, so assembly drawing is also required when someone is assembling your product in real world. Okay, they should know that what kind of parts are going to use you are going to use. So as you can see here, uh, you can guide them with these views. Okay, there are also isometric views, and these views are readily available. Like AutoCAD, you don't have to create these views separately. You don't have to create these arcs, these lines. These are readily available. This isometric view is also readily available. The only thing you have to create is parts and assembly 3D models of them. Okay, and the drafting process is very easy. Okay, so you can see here that different parts are there, and these balloons are indicating that what part number is there. Okay, and from these balloons you can trace those numbers in that in this table, and this table is called bill of material. Okay, like first number, item number 1, search for the item number 1. Item number 1 is this. What is this? It is fan housing, description and quantity. And then what is this 12 number? Okay, let me search for the number 12. Okay, this is here. So 12 is, what is there? 12 V belt type. Okay, so this is your belt, and how many belts are there? There is 2 quantity. Okay, so quantity will also be mentioned here. So any worker is going to make your assembly easily using this information. Okay, he should have the knowledge that what kind of component is going to wear. Okay, and for that also you also have if a worker is not very capable, then you can also share your exploded view with him. Okay, in a separate drawing. Okay, and that will communicate your design even more efficiently. And then there is, you can create also sheet metal and fabrication structure. Okay, you can see here that this housing is made of sheet metal. The sheet metal section is separate in every parametric software, because when you bend any sheet, you guys already know that sheet metal, for fabricating sheet metal there are various processes are there, like bending, forming, blanking. Okay, so such kind of processes are there to required to make these sheet metal parts. And when you bend any metal, it deforms your part, and the total length will be changed. Okay, and then when you want to make your design in real world, you have to know that what kind of sheet will be required, what kind of raw material length and width of the sheet will be required, and for that you have to provide bending allowances. Okay, it will compensate for the deformation and will calculate the total length of sheet, raw material sheet, which is required to make this part. Okay, because in the market you only get the flat sheet. Okay, you don't get these curved sheets. So calculating that flat sheet length is very easy in these two softwares. Okay, like you can see here, there are flat components, there are curved components. Okay, and all this will be welded together and this housing will be made. And then there is structure. So this structure that you are seeing on which this housing is resting is your fabricated structures. Okay, uh, for making these structures you just have to create sketches, and the channels that are you are seeing here, like there are these L channels. In the bottom there are C channels. Okay, these channels will be readily available in your library according to the standards that are used in the industry. Okay, there are standards like ISO, uh, ENSI standard, okay, in inches, in metric system. Then there is Japanese standard, GIS standard. Okay, DIN standard is there, BIS standard is there. So according to which standard that your company is going to use to make this structure, you can directly take these channels and make your structure. You just have to create the sketches of this structure, and you can place your channels according to where they are needed. And lastly, you have to do the adjustment according to sizes that you need. And the structures, you will get such structures. And then there are motors. Okay, you can see that there is a motor. You can also make electrical components also in here. Okay, and these okay, softwares are very greatly advancing in electrical department also. Okay, in schematics, in component creation. Okay, 3D models of your electrical components also. So that is also going to come. Okay, then there is simulation capability. Okay, you can simulate your products very easily in here. You just have to know your boundary conditions. Okay, like I have simulated the bearing house here, and you can see the end result here. Okay, but before the end result, there is a whole process of determining your parameters, providing your fixtures. Okay, then generating mesh. So what are fixtures? Fixtures are the features that you apply on your products when you simulate your product. Okay, you have to know that how your product is going to be fixed in real world. So I know that my product, this housing is going to fixed using these bolting holes, and the bolts will hold this product in position. So my fixtures are going to be in these holes and the front hole. So these 9 holes will be fixed. Then there are forces. You have to know which kind of forces are going to be applied on your product. Okay, there can be multiple forces. Okay, like force is going to be there in newtons. Then there can be pressure in newton per mm square. There can be torque. Okay, then there is shear force is there. Okay, so different kind of forces are there. Centrifugal force is there. So you have to know your forces. You have to apply those forces according to the amplitude that is going to affect the component. Like if I say that 100 kg of shaft will be placed, of weight will be placed on in this bearing house, I will provide 100 kg load here. Okay, and the weight of shaft will be simulated here in the direction that is I have specified. Okay, in the downward direction, because the gravity acts in the downward direction. Okay, and you can also simulate your components, virtual components here, like bearings, bolts are there. Okay, you can also provide torque in it. So in industry, some of the bolts are tightened with a predefined torque. Okay, because some of the components require less torque and some of the components require more torque according to the application where they are used. Okay, so this is the simulation result. And before simulation, you also have to do meshing. What is meshing? Meshing divides your component in several finite elements. Okay, because your computer cannot calculate the whole model. Okay, it calculates piece by piece. So matching is what it makes your product in pieces. Okay, okay sorry it divides your products in finite elements, and your computer will do simulation on each piece, and it will interpolate all the results and give you the whole result and the final result. Like you can see that the yield strength of this product is 241 newton per mm square, but the maximum stress that you are getting according to the conditions and loads that you have provided is 5 newton per mm square. So you can make out from this that your product is relatively safe, and your factor of safety is very very high. Okay, in industry, generally the factor of safety is taken between 1.5 to 1.7. Rarely they go above 2 or 2.5, because when you increase factor of safety, the mass will increase, and when the mass increases, the weight increases. Okay, and in lot of application, weight increment is not allowed. Okay, and it also increases the cost. Okay, so it is not like that you can increase your factor of safety to whatever limit that you want. Okay, it also maximum limit is also there, and in minimum side it should be 1.1 to 2. Okay, the standard ratio is 1.1 to 2 according to the material you are working with. Now there is a question answer session. Okay, so if someone has any question regarding the session that we have conducted today, or the software regarding we have covered today, you can ask questions about this software, and we can answer your questions. Are there some students?
Sorry. Hello. Hello, sir.
Hello?
Hello.
Hello?
Yes, sir.
Yes, I
Can you
can
hear
hear.
me, sir? Hello.
Yes,
Yes,
yes.
yes, I can
Yeah,
hear.
okay, sir. So time is 11:30, sir. 11:30, sir, and time is already up, sir. So the questions from this, but we are given that questions on your contact number, sir, and then after that answers we share with our students, sir. Is it okay, sir?
What are you saying? I couldn't get you.
Actually, the time limit is 10:30 to 11:30, so that time limit is closed, sir. So the questions
Okay.
related to softwares we are getting from the students, but we WhatsApp
Okay,
to
okay.
you. So that's questions.
Okay,
Is
no
it okay,
problem.
sir?
We can solve their queries. And these are the
Yes.
software that you use for designing purposes. And electrical side also you use AutoCAD. There is MATLAB Simulink. Okay, for making your products and simulate them as per the real world conditions. You can also use in electrical side ANSYS Maxwell for simulating, making your products and simulating according to the real world. Okay. In electrical sides, those softwares are used.
Yeah.
In mechanical side, these Creo, SolidWorks, CATIA, NX, these software are used
Yes.
for computer-aided design, computer-aided engineering, and
Yeah.
some of them used for CAM also. Okay, but CAM field is totally different. And in civil side, there are these software, as Kapil sir mentioned today, that the softwares like Revit
AutoCAD,
is there,
Revit,
or AutoCAD is there.
StatPro for the
Okay.
interior and architecture field. You can go for the SketchUp 3ds Max.
Yeah, SketchUp is also there. It is just like 3ds Max, and it is used for modeling and non-technical purposes.
Yes. Yes. Definitely, sir. And thank you so much, sir, to give us valuable and precise time to boost the knowledge
Okay,
related to
just two
various
minutes.
designing
Then we will
softwares to
conclude
us.
this session.
Yeah. Yeah. Okay.
Okay, so
Perfect.
these are the courses that we offer and that you can do. Okay, like AutoCAD in civil interior and architectural side. AutoCAD is there for drafting purpose. Revit is there for designing purpose. Revit structure is there for structural requirements. Okay, Revit architecture and structure are both are different fields. Then there is 3ds Max for modeling, interior design, and architectural applications. Okay, you can make a whole interior space using the 3ds Max. StatPro is there for analyzing your structures. Okay, how safe your structure is, how safe your building is. SketchUp is there. SketchUp is basically just like 3ds Max, but with some of the less capability of rendering. But it is very easy for modeling. Okay, and it is used very vastly in different fields. So SketchUp is there. Then there is V-Ray. V-Ray is used for rendering. You can take out these realistic looking renders. Okay, if you visit any schemes, then you can see that they have brochures, and those brochures contains images of renders. Okay, but those renders are realistic looking, and uh, if you see those renders, you can make out that it is real or fake. Okay, then there is Photoshop. These renders that you have taken out from the V-Ray, you can edit them in Photoshop according to your needs. Okay, Photoshop has a very different photo editing software, and many of the fields you can use it. And then there is mechanical. AutoCAD is there. Okay, AutoCAD is very common. Okay, each and every engineer can use AutoCAD. Then there is Fusion 360 Autodesk product. Inventor is there. It is also a Autodesk product. Then there is SolidWorks Dassault System product. Creo is there. It is PTC product. All these softwares are used for designing. Okay, and CAE also. And then there is MasterCam. MasterCam is specifically focused on CAM. Okay, computer aided manufacturing. You can create your programming codes in here. Okay, many of you know that there are G codes and M codes. Okay, G codes controls your tool path, and M code controls your machine components like coolants on off. Okay, speeds are there. So these codes are generated in mastercam automatically. Okay, you don't have to manually create them. So this is specifically used for cam. Then there is ANSYS, and in ANSYS also there are two modules. FEA is there and CFD is there. Okay, so ANSYS is basically focused on only on analysis. Okay, you don't create models here. For models you have to use these softwares only. Okay, like SolidWorks, Creo, Inventor, Fusion. But for analysis, for high level analysis, you can use ANSYS. And FEA, in FEA you can use structural analysis, like your product is, what kind of stresses your product is going to face, what kind of vibrations that your product is going to generate. Okay, then there is CFD. In CFD you can analyze your design. Okay, like aerodynamics of your product, how your fluid is going to flow from your pump. Okay, so those kind of applications you can analyze in CFD. Okay, regarding the fluids. Okay, fluid contains fluid in category of fluid, air is also comes, air and all kind of fluids. So these are the software that are used in cam, CAD, cam, and CA. What are our services? So we also provide lifetime membership is there, centers across state. Then free demonstration is also there if you want to visit here. Online and offline, both classes are present here, and placement assistance is also here. Okay, many of our students are placed in reputed industries. Okay, so I'm concluding this session today, and I hope today's session was very informative. And if anyone have any questions, those questions we are ready to solve, and solve your queries about regarding today's session, or software that we have presented today, or any of the software on any query regarding the designing field. Okay, so thank you, Parul University and the
Okay.
faculties that have introduced us and presented us the opportunity to showcase the importance of designing software, and share our knowledge with them.
Thank you, sir. Thank you so much.
Okay.